Hi, my name is Wong Hui Yong from BELK3. Today, I would like to explain about Assignment 2, Question 1a. Okay, first, let's look at the given value. We are given the transmission parameter, where is A is 4, B is 30 ohm, C is 0.1, and D equal to 1.5. The load impedance connected at the output is 10 ohm. Next, because the transmission parameter or ABCD two-port network, we use the standard equation. V1 equals to AV2 minus BI2, I1 equals to CV2 minus DI2. Now, I substitute the given value into the equation. So, we get V1 equals 4V2 minus 30I2 and I1 equals 0.1 V2 minus 1.5 I2. Next, let's look at the output side. The load impedance here is 10 ohm, so the relation between the output voltage and current is V2 equal minus I2 times ZL. Substituting the value of ZL, V2 equals minus 10 I2. Now, I substitute V2 equals minus 10 I2 in the both equation. For the first equation, V1 equals 4 times minus 10 I2 minus 30 I2, which simplifies to minus 70 I2. For the second equation, I1 equals 0.1 times minus 10 I2 minus 1.5 I2, which simplifies to minus 2.5 I2. Next, the input impedance is defined as Z equals to V1 divided by I1. Substituting the value of V1 and I1, Z equals minus 70 I2 divided by minus 2.5 I2. After cancelling the I2 terms and the negative sign, the input impedance is 28 ohms. So finally, the input impedance of the network is 28 ohm.
Assalamualaikum, my name is Amir Fazi bin Amsari from BLK3. I will answer for question B and question C from assignment 2. So for question B, we need to find the value of I1, I2 and V1 and V2. So for I1 from the circuit we know that I1 is equal to I2 ohm. So we use current divider to find I1. So I1 is equal to 4 over 2 plus 6 times I total. So it will be 2 ampere for I1. Number 2 is for V1. So as we know from the circuit, V1 is equal to Vn, and Vn here is equal to 4I4 ohm. So for I4 ohm, from the circuit we know that IT is equal to I1. IT is equal to I1 plus I4 ohm, and I4 ohm will be IT minus I1. So I4 ohm will be 3 minus I1. So I4 ohm, as we know that 3 minus I1, we put in the formula back, it will be 4 times 3 minus I1, and V1 will be 12 minus 4I1. So to find the value of V1, as we know I1 is equal to 2 ohm, 2 m. So V1 will be 12 minus 4 times 2 will be 4 volt. So number 3 is I2. As we know from circuit, I2 is equal to I1. So I1 here is 2 ohm and same to I2. So I2 will be 2 ohm also. So number 4, find the V2. V2 is, as from the circuit we know V2 is equal to 10 I2, and I2 here is 2 m. So 10 times 2, it will be 20 volt. So for the question C, the question asks to represent the circuit in frequency domain, as the circuit given is in time domain, so we need to convert it from time domain to frequency domain. So there are various of formula. So these 4 formula we need to use to convert from time domain to frequency domain. So for number 1 is for exponent, for the current source. For the current source, we use formula exponent negativity equal to 1 over s plus a. So negative exponent negative 2t will be 1 over s plus 2 ampere. So for resistor, the impedance is z equal to r. So z for 2 ohm is 2 ohm, and for z 1 ohm it will be 1 ohm. So for capacitor, the impedance is 1 over SC. So capacitor here is 1 farad. So 1 over S times 1 is 1 over S ohm. So for inductor, the impedance is S times L. So L is 2 Henry. So S times 2 is 2S ohm. So we convert into the circuit. It will be, the capacitor will be 1 over S, the inductor will be 2S. For resistor 1 ohm, it will be 1 ohm. For resistor 2 ohm will be 2 ohm. And for the current source will be 1 over S plus 2 ampere.
Hi, my name is Kalayara Sumarimutu. Today I want to present assignment number 2, question number 4 from subject of Advanced Electrical Circuit. The question is, using Laplace transform method, determine the time domain expression for the capacitor voltage Vt in figure D, taking into account the initial capacitor voltage V0 equal to 5V and the initial inductor current I0 equal to negative 2A. In the circuit, we have the resistor 10 ohm, inductor 4 Henry, capacitor 1 by 8 farad, source negativity A. So first we want to do step number 1, transform component to the S domain. First we identify the domain impedance and account for the initial condition. It is V0 equal to 5 voltage and I0 equal to negative 2A. So now V2, this is need to flowing into same direction as I. Current source IS equal to 4 by S, resistor 10 ohm, ZR equal to 10, inductor 4 Henry, ZL equal to 4S. So the current flow is the IL equal to 0 by S equal to negative 2 by S. The capacitor is the initial voltage V0 is represented by the parallel current source. So the capacitor is 1 by 8 farad ZC equal to 8 by 5. So the method is IC C multiply V0 equal to 1 by 8 bracket 5 equal to 5 by 8. So after this we need to, step number 2, after this we need to apply nodal analysis KCL. KCL is, we sum the current learning the top node. V bracket S by 10 plus Vs by for S plus negative 2 by S plus Vs by 8is negative 5 by 8 equal to 4 by S. So let me combine the Vs term to and move consistent to right away. So Vs 1 by 10 plus 1 by 4s plus 5 by 8 equal to 4 by s plus 2 pi plus 5 and 8. After combine, we need to multiply both the side 48. 45 plus 10 plus 5, 45 plus s root 4 2 equal to 6 by s plus 5 by 8 equal to 48 plus 5s by 8s. Step number 3, we need to complete the square for the denominator. The denominator s is 2 square, s square plus 0.85 plus 2 equal to s times 0.4 square 2 plus 1.84. Let a 0.4 and w square root 1.84 equal to 1.356. So we need to inverse this to complete the square for the denominator. Denominator is the e exponent negative at cos wt and exponent at sin wt. So v is 5 s 0.4 plus 46 by s 0.4 square 2 plus 1.84. So last step is we inverse Laplace transform. The last transform we applying two transfer to two term. First term become 5 exponent negative 0.4 cos bracket 1.356 t. Second term become 33.92 exponent negative 0.4 t sin bracket 1.356 t. So the final answer is v t equal to exponent negative 0.4 t bracket 5 cos bracket 1.356 t plus 33.92 sin bracket 1.356 t bracket uv. Thank you.